In this video, we are going to learn about equation tape diagrams, which are related to the tape diagrams we've used before in solving ratio type problems. For your vocabulary, you're going to write down that an equation tape diagram is a visual model, just like how ratio tape diagrams are visual model, that can help write and solve equations to find missing numbers. Let's start by looking at two different tape diagrams. They're both going to be 10 boxes long in your spiral. First one, we're going to break up into 5 pieces with 2 boxes in each piece. The second one, we're going to break up so that it has 1 box with 2 pieces and then a bigger section with 8 pieces. We're noticing that both are a total of 10. All right, so what type of equation could each of these represent? Let's look at some possibilities. I want you to think for a moment and decide which equation matches with which tape diagram. So I notice that this one has 5 groups of 2, which is sort of like saying 5 times 2. And this one here has 1 group of 2 and a group of 8, which would make it like a 2 plus 8. And both of them equal 10. All right, let's look at another tape diagram. So first of all, notice the way I've drawn this. I've said that each section is worth 3. Even though on my graph paper, I've only put 2 boxes in each section. Just like with ratio tables, the boxes do not have to represent, they don't have to be the same size as the number that they represent, right? I did that on the last one. They do not need to normally. Okay, so I want you to go ahead and try and write an equation that you think could represent this tape diagram. If you can, see if you can think of more than one way to write it that would match with this model. So the first thing I see is that I have 4 3s here, 3 plus 3 plus 3 plus 3, and that equals a total of 12. That's true. That works. I also see, well, there's 4 3s, so I could think of that as being 4 times 3. Gives me 12. Both of those work. Now let's try it the other way. I want you to draw a tape diagram. 3 plus 6 equals 9. Make a tape diagram for that equation, please. Do it now. Does your tape diagram look like this? Don't forget to write underneath what the total amount is. All right, now let's try some where we don't know all of the information. Let's try some where we use a variable. So this time, we're going to make a tape diagram where we have a section of 3, but then we have a section that we're labeling X. And we don't know how big this part is. Now you might be tempted to count boxes, but I'll tell you right now that even if I've drawn my model beautifully so that you can just count how many squares there are, that doesn't mean that's how many there actually are. The variable is usually not going to match what the model shows because the X is just representing an unknown quantity. What I am going to tell you, however, is that the whole thing equals 15. So I want you to go ahead and see if you can write an equation here. Your equation is still going to have the X in it. Did you write 3 plus x equals 15? That's what I would have done. Of course, there are other ways we could write it too. We could say x plus 3 equals 15. That's also true. We could even say that 15 minus 3 equals x. That looks like it has to be true, right? If you take the total of 15 and you take away 3, that'll leave you with what's left over. We could also say that 15 minus x equals 3. Or we could even say that x equals 15 minus 3. In elementary school, you might have talked about this as being like a fact family. It's the same idea. It's important we can recognize that all of these are conveying the same information. All right, let's try it again. Please write down all the different ways you could represent this equation tape diagram using an equation. Make sure that your equation still has an x in it, and do not be tempted to count boxes. So I started out with 4 times x equals 20. As a side note, you'll also sometimes see this written as 4x equals 20. Often we'll leave off that multiplication dot when we're writing algebra. If we're doing what's called a coefficient in front, coefficient in front of the variable. That means that the coefficient is always multiplying by the variable. It's just a number out in front of a variable. Or we could do x plus x plus x plus x equals 20. Or I could say that x equals 20 divided by 4. Now, it's possible that some of you might be wondering why we're doing this when you can look at this and perhaps you very easily see that x equals 5. For some people, it may not be so easy, and that's totally fine. The point here is not to make it harder to just solve 20 divided by 4 equals 5. The point is that we're building the building blocks for the algebra that you're going to need to use in later classes. So we're starting off with kind of basic situations and simple numbers to try and build these skills for how to write these equations. So the point here really isn't to find the 5. The point is to feel comfortable understanding how all these different representations are related. So writing the equations is the important skill I want you to work on, not just finding the answer. Although we will be doing that too, of course. All right, and let's do one more example before we get to that practice problem. So I want you to draw a equation tape diagram for each of these, please. Do it now. So the first one, 3 plus y equals 18. That should have one section of 3 and another section of y for a total of 18. And the one that's 3 times y equals 18 should have 3 sections of y's for a total of 18. Hopefully you can see that you're going to get a different value of y for each of these, right? In this one, you're going to get that y equals 15, whereas in this one, you're going to get that y equals 6. All right, for your practice problem, I need you to draw me 2 equation tape diagrams. One for the equation 5 times x equals 15. I'm going to make that times dot a little bit better there. 5 times x equals 15. And the other one for 5 plus x equals 15. Draw a tape diagram for each.